If we're looking at the area, the surface area of a cone, we notice again it has a curved surface area, so the curved roundy part, plus a base which is actually a circle. Okay, now if we take a look at the curved surface and we actually look at the area around, we can maybe just put a paper around to make a cone, and we open that paper, we'll notice that this is actually the sector of a circle. Can you see it's a sector of a circle? Where this is the radius here, down here, and there is usually an angle here. Here's the angle. Okay, so you can see here we can say the curved surface is in fact a sector. Maybe my sector doesn't look the same as that one. It looks more like a much smaller sector, a smaller piece of the circle. That's because my cone was quite tall. If I made a shorter cone, then opened that up somehow with one hand, you can see that it resembles more, it looks more like the one that's given in the diagram. So you will notice that the sector here has this radius, which in fact came from, if I put that back together, it's the slant height. It's the slant height. So the radius of this is actually as a slant height. You can try that yourself at home, and you will notice that this L here is the radius of the sector. Okay, so you might get a question that actually tells you to find the curved surface area of a cone which is made out of this sector, in which case the curved surface would be the area of the sector, which I don't know if you remember, that is theta over 360 times pi r squared. However, we're not going to focus on that angle, but using this theory, it would lead us to a formula for the curved surface area of a cone. The curved surface area of a cone is pi r L. Okay, pi times the radius times the slant height. The radius is at the base here where the circle is. So we're not talking about the radius of this. When we say radius, we mean the radius at the base. Okay, the total surface area of the cone must be the curved surface area plus the area of the base, which is a circle. Yes? The curved surface area we've just said is pi r L plus the area of a circle is pi r squared. Okay, now let's have a look at a couple of examples. I haven't left much space here, but let's look at this first one here. If we needed to find the total surface area, we'd first find the curved surface area. So we'll find the curved surface area of this. The curved surface area equals pi r L, which is pi times the radius, which is 4, times the slant height, which is 19. So 4 times 19 is twice 38, which is 76. This is 76 pi. If I'm not mistaken, yes. Okay, then we have the area of the base here. The area of the base is the circle. Okay, so the area of the base equals pi r squared, which equals pi times 4 squared, which is 16 pi. So if I want to find the total surface area, I'm just going to add those two together. So we're going to say the total surface area equals 16 pi plus 76 pi, which altogether makes 92 pi centimeters squared, which we should know is around 300, because we know pi is worth 3.14, so almost 100 times something a little bit over 3 will be around 300. I'll just put that in my calculator and I will get 289.02 or 289 centimeters squared. Okay, let's look at this one beside here. We have another cone here. In this case, we don't know the slant height. We know the perpendicular height, which is useful when we're finding the volume. We need the perpendicular height for volume because that's a third base area times the perpendicular height. But we actually need the slant height when we're trying to find the curved surface area. So we need to find this slant here. So if I'm looking at this right angle triangle here going through the middle, I'll just label that. I can label it L as it is a slant height. I'll label it L. And I'll use my Pythagoras theorem to find that. So L squared equals 12 squared plus 7.2 squared, which means L squared equals, what is that? 195.84. So L equals the square root of that, which comes to a nice 13.994. I can just call that 14. It's so close to 14 that I will call it 14 instead of putting this completely accurate answer in this time. Right, so how am I going to find the surface area of this? First, I need pi RL, so the curved surface area. So the curved surface area, I'm just thinking where I can actually write this. The curved surface area equals pi RL, which equals pi times 7.2 times 14, which is going to come to 84.617. The base area is pi r squared, the area of a circle, which is pi times 7.2 squared, which equals 162.8602. Okay, and then I need to find the total surface area, so I will add these two to lead me to the total surface area. So total surface area equals my 84.6170 plus my 162.8602, which will come to 247.477. Or to three significant figures, just 247 centimeters squared. That's fine and dandy. Now let's move on to this example here, example 8, which will be our last example. Okay, here it's just giving me words, no diagrams. It's telling me a cone has slant height 7. So the L is 7 centimeters. Here it is here. It's my L, which is 7 centimeters. It then says the curved surface area is 28 pi. So the curved, I always write my given information first, is 28 pi. Now I know a formula for curved surface area, and that formula is pi RL, which is 28 pi. I have two unknowns here, the R and the L, except the L is not unknown. They've already told me it's 7. So pi r times 7 equals 28 pi. As all of this is multiplied, I can bring the pi and the 7 underneath to leave me with the r. So I'll divide that by 7 pi. And I don't really need a calculator for this. I can if I like, but I don't need it. These two cancel. 28 divided by 7 is 4 centimeters exactly. That's the size of my radius. Right, and that's about it for spheres, cones, and pyramids. we need to bear in mind for questions like, for example, these ones that have two shapes. If we need to find the surface area, we have to think about the outside of this shape. We have a cylinder here and it has a sphere on the top. So what is actually showing in this shape? If I'm going to find the surface area of this, I will need the curved surface area of this hemisphere. So it's half a sphere. And the curved surface area of the cylinder plus this circle here is not showing, it's actually covered, it's inside, plus the base circle, because that actually shows at the bottom. So I'm going to have to add all three of those. All right, so there are various different other problems we could do. You just need to practice. You have the basic tools to find surface area of cone, sphere, and pyramid. Or in the order we did it, it was actually pyramid, sphere, and then cone. That's it. Bye for now.